Hi folks, we're going to take a look at page 363, number 7, and this is an interesting question because we're not actually going to solve for anything numerical here, but we're going to make an argument using a diagram. So it says, using a diagram, explain why it's easier to do chin-ups when your hands are 30 centimeters apart instead of 90 centimeters apart. Okay, and when you think about it, imagine yourself trying to do chin-ups. I think it won't be too surprising that it would be easier the closer your arms are. But let's justify that using vectors. Okay, now they give us an important piece of information because we're assuming that the force exerted is the same in both cases. Okay, so if I'm drawing a vector representing the amount of force that's being applied by each arm, it's going to be the same length in both cases. Okay, but if I draw, again, often draw a situational diagram first. So let's say we have our arms further apart. Okay, so this is 90 degrees. All right, well, we have our angle from the horizontal for the force that's applied in each direction. Okay, let's call it theta, and we'll assume that we're located right in the middle. So this is also theta. But then if you have your arms closer, well, then the angle from the horizontal is going to be bigger. So say we call that one phi, and again, it'll be the same one on the other side. Okay, so now let's use this to draw, and again, the length of each vector, the amount of force being applied is the same in all scenarios. Okay, so let's draw the 90 centimeters apart. Okay, so I'm just going to add these two vectors together, but I'm going to add them tip to tail. All right, so say I start here. Well, I have my horizontal, and I see my angle theta, and I'm going to draw my vector, which say this is the length. This is the length of vector that represents the force that my arm can put. And then I've got theta, and then here I'm going to draw a second vector, which is going to be the exact same length, except now it's going to be theta degrees from the other horizontal. Okay, so there we go. There's my theta, and there is the vector produced. Okay, so this is the resultant force. And take a look at what that looks like. Now let's take the 30 centimeter scenario. Now I'm going to start this a little lower, and you'll see why in a second. Because remember here, the force is going to be the same. So it's going to be the same length, except applied at a different angle. Okay, so try to draw it so it's about the same length, except now it's angle phi, and then same thing here, the same length, but with the angle phi. And look at my resultant vector. My resultant vector here is clearly larger than the resultant vector created there. Okay, now of course this assumed that the force exerted was the same in both cases, but when I add the two vectors with this larger angle from the horizontal, it produces a larger force vector, a larger resultant vector than if the angles are smaller. Okay, so this justifies this idea that it's easier to do a chin-up with your arms closer together than further apart. All right, that's it for this one.